Hello, everyone, and welcome to another episode of BMed 202. In this episode, I will show you how to draw the foundation footing detail for a strip foundation. Now, the foundation that we're going to look at today is related to this foundation plan. Now, this is our foundation plan for a simple two-bedroom dwelling. This is the two-bedroom. You have a bedroom at the front and at the back, to the right, to the left rather, a bathroom in the middle, a porch, living and dining, kitchen. A very standard two-bedroom dwelling. These dwellings are very common in Jamaica and I'm assuming in the Caribbean as well. Correct me if I'm wrong. So this is the foundation plan. If you don't know how to draw foundation plans, please revisit the video in BMed 101 that is related to this, to drawing foundation plans. Now this is the foundation plan. Now this is representing a concrete block wall, right? And a strip foundation is the foundation of choice for a concrete block wall, right? Because the foundation strip is the support system for the wall. The wall is built on the strip foundation. Now, I'm going to show you how to draw this strip foundation, and along the way, I'm going to explain certain measurements that are used and certain how the strip foundation is built. Now, let's start off with drawing what we call the foundation footing. Now, the foundation footing is the part of the foundation that the wall will rest on. So normally there are different measurements that are required. If you notice here, you have the foundation width or the trench width. So basically what is happening here, you have trenches that are dug and you have the wall that is laid. The blocks for the walls are laid in the trench after the strip foundation is casted. Now, one of the critical measurements that you need is the width of the foundation. In this case, as you can see, it is labeled as 450 for the entire foundation. So I'm going to firstly draw a line 450 millimeters. Now, I am going to draw, alright, after drawing, let me just extend this line. This line will represent the foundation depth. I'm going to, for this specific foundation, the depth is 900 millimeters. So I'm going to offset this line 900 millimeters. Now, this is another measurement that we need. On the floor plan, we are not able to see how deep the foundation is. The foundation footing detail will show this. Now, this line represents the depth of the foundation. This line represents the ground level, right? So the measurement that I've used is 900 millimeters. Now, 900 millimeters is the minimum depth that is acceptable for the depth of a foundation trench. Now, it can be more. It can be 1,200, which would be 4 feet. It can be 1,500, which is 5 feet. It depends on the situation, the soil type, the amount of load being supported by the foundation. So let's go ahead. Let's continue. All right, I'm going to offset 300 millimeters. That is 1 foot from this foundation footing line. And this line now represents the thickness of the foundation footing, the thickness of the concrete, the reinforced concrete footing. All right, so after doing that, I'm going to just select a random point on the foundation footing to draw a line. Then I'm going to measure the thickness or the width of the trench rather 450 millimeters, which is shown here. So I can now go ahead and trim off these lines as they are no longer necessary. All right. Now, if you notice, the wall thickness here, I've not labeled the floor plan, but the wall thickness here is 150 millimeters. The wall thickness varies, depends on what you want, but in this case, it's 150 millimeters. Now, since this is 450 millimeters, then you know that 150 plus 150 plus 150 gives you 400. So you can simply measure 150, draw a line upwards, then another 150 from the other side, and you draw another line upwards. Now this wall, the thickness, this is representing the wall. The thickness is 150. There's another way that you can get it. Let's draw a center line, and then you will offset 75, which is half of a 150, on either side of that line. You can now go ahead and delete this, and here you have the wall. I am going to now go ahead and trim this portion. Now, in drawing the foundation footing, I'm going to show the ground level on one side. I'm going to show the floor level on the other side. All right, so let's go ahead. I can shorten this line a bit. Doesn't have to be that far out. This line, what I'm going to do with this line now is shift it further upwards. And the height that I'm going to shift it will be equivalent to the floor level inside the building. So let me use 300 millimeters. Now the floor level is dependent on the builder and the client to some extent. I said to some extent because sometimes the client does not know what is best, but the client may have their preference. Now, 300 millimeters is a common measurement. I'm going to measure, and you will realize the vertical distance between the floor level and the ground level is 300 millimeters. So this is the ground level, this is the floor level. Let's do that again. This is the ground level, this is the floor level. Now this is the foundation footing that I've just drawn, the strip foundation footing. Let me do a little bit of demonstration. So basically this strip would go along in the ground, and the wall would be resting along in the ground. So this is the concrete wall. Let me delete this line for a bit. So this is the concrete wall. That's how it happens in the foundation. Let me undo so I can continue. All right. So we all know that if you do building technology or construction or subjects that has to do with constructing buildings, you will know that there are different layers that make up the floor inside of a building. We have to represent those in the foundation footing detail. All right, so let's continue. I'm going to now I'm going to offset this floor level 100 millimeters. Now this distance that I'm offsetting will represent the thickness of the floor slab, right? This is dependent on the builder or the person designing the building. Some persons use 150, it all depends. I'm using 100 millimeters. That is 4 inches. I'm going to offset once more, 100 millimeters, and this layer is now going to represent the sand blinding. And we should all know what the purpose of the sand blinding. I'll explain the purpose of each part in a bit. And I'm going to now offset 300 millimeters. All right. Or should I go 400 millimeters? Let's go 400 millimeters. All right. Now, this third distance or this third layer represents the hardcore layer. All right. So this is the ground level right here. This is the floor level. This space here is the concrete slab that is serving as the ground or the floor. Below the concrete slab, you have sand that is acting as the sand blinding. Below that, you have the hardcore layer, and I'll soon explain what the hardcore layer is. So we are getting there. Now we have to show the steel work that is in the slab, or not in the slab rather, the foundation footing. Now I'm going to offset 50 millimeters, and the reason why I'm offsetting 50 millimeters, normally when you are applying steel into a foundation or anything that will go in the ground, you normally apply, the steel is normally placed in such a way that there is a 50 millimeter space between the steel bars and the dirt surrounding. So there's a 50 millimeter cover, you call it, refer to it as cover, right? So that, because the steel bars, when they are placed in the foundation, they should not be placed directly on the ground, because when you throw or pour the concrete to cast the foundation, those steel bars will be exposed to the earth, which consists of salts and other minerals and moisture, of course, that will very quickly cause the steel bars to rust. And when they are on the ground, they will not be acting as a part of the concrete footing to bear the load properly. So you have to have what we refer to as a cover. All right, so I've offset 50 millimeters, and I can bring this down now. I'm also going to bring this down. All right, I'm going to now use the fillet command. So this is the steel bar that is resting on the ground. That is spanning from one corner. It's spanning across the width. I am going to fillet, or you can let's bend. Let's fillet it. I'm going to use the fillet command. I'm going to press R for radius, and then I'm going to change the radius to about, let me see, 25. Can 25 work? All right. So this is working. All right. Now this steel bar. I'm going to use different line weights. Let me see. All right. This is good. So this represents the link that would link the main bars in the foundation together. All right. So now I'm going to draw 3 circles, each having a diameter of 12.5 millimeters or 12 millimeters. It doesn't matter that much. All right, let me put them a bit bigger. All right, so this size is okay. You don't have to draw it specifically, the size of the steel bar. You just need it to be large enough to be shown. I'm going to use a solid layer. All right, so now I can copy this to one side, then mirror it to the other side. You choose your method of doing this. I think I may want them a bit bigger. I should have drawn them a bit bigger. So this is what I'm going to do. I am going to select the object, then let me see if 1.5 would work. I think probably I'd need to make these a bit thinner. All right, so because when I'm zooming out, I'm not necessarily seeing the circles. The circles that I'm drawing, they represent steel bars. So in the foundation, let's say this is the foundation, the trench that was dug. All right, this is not working out. Okay, hold on. All right, there we go. So this is the trench, and you would have one steel bar here, and it would not be on the ground. It would be propped up by stones, small stones. You'd have another one here, and you'd have another one here. So this is in the ground. All right, and this steel bar would be under it. Something like this. Um, and it's overlapping a bit. So this is what is happening here, right? So it's being represented like this. All right, so I'm going to draw another line in the middle. I'm going to draw another line like this. I'm going to also fillet, then match properties. I'm going to pull this down some more. So let's click all three parts. I'm going to move this down some more. I think I probably can move this over a bit. Yes. All right, so this is what I'm basically drawing. There's a steel bar that is placed vertically in the foundation. So when the foundation is casted, meaning when the concrete is poured on the steel bars, there are vertical bars that are placed at intervals. Let's say so that one is here. Just trying to illustrate something here. And they are placed at specific specific distance apart. All right, and they are set to stand vertically in the foundation before the concrete is poured. Then once the concrete is poured, they will now sway in the air. They are normally propped up with other steel bars, after which the concrete blocks will be placed over these steel bars as they are laid. All right, so this is what we're representing here. After which we are going to draw a line, a zigzag line, to show that the floor, there's continuation in the floor. Zigzag line shows continuity. You are also going to put one, let me say, somewhere here, because this concrete block wall is it's a bit long. We don't need it to be that long. So we can trim off what is here. All right. Now there are some things that we are going to do here. One of which will be to add some, what we call it now, we're going to do some hatching to represent the different elements. For example, we're going to hatch the space here. We're going to select the architectural concrete hatch to represent, let me see if I can find it. The appropriate scale in this case could be 15. All right, it works. You need to click here also because the ground floor is actually concrete in this case. We are also going to hatch here. In this case, we're going to look for architectural sand. And we are supposed to be able to find it. And that's it. That represents sand. Then representing hardcore, let's search again. Hatches. You're going to see stone or something like that. All right, gravel. All right, this works. Now, if you notice it's very small, you don't want it that small. Let's try 150, and that works. Let me see if 200 would be better. Yeah, I prefer this. Okay, so it's coming along nicely. Let's now hatch the walls. Now, some persons, what they would do, and I'm going to demonstrate it. Let me demonstrate it first. All right, so let's get this out of the way. All right, some persons, what they would do, they will literally draw the blocks. So that would be 200 millimeters. The height of a block is 200 millimeters, a concrete block. So one block, two block row, three block, four, five, going up. All right. And this would represent the concrete block wall. Others would do this. They would use the hatching that represents a concrete block wall. Let me see if I can find it. It's supposed to be in ISO or ANSI. All right, this works. Let me make this larger. So this arch represents a concrete block wall. Some persons prefer this, but for this application, I prefer this. All right. So we're almost through drawing the foundation footing. We have to label it very shortly. There's one more thing that I should show, and I'm going to use the spline to create a border around the concrete footing because I need to indicate the earth. So I'm going to hatch once more. If you notice, I'm pressing for the hatching. I'm pressing. There's the command is there somewhere. I don't quite remember where it is. The icon that is. I'm pressing H, then enter, clicking in the space, and I'm changing. If you notice, it hatches the last hatch that was used. So let me go to hatches. Let me search for earth. All right, that is ANSI, other predefined. Let's go down for earth. It is there somewhere. Okay, that is earth. Let me try 300. Now, I can remove this now. I don't need that anymore. All right. Now, sometimes I like to do this. I like to change the angle to 45 so that it is like this. It doesn't matter, but this is my personal taste. All right, so we are almost through. There's one more thing that is normally shown. I'm going to copy this and I'm going to place these at 600 millimeter intervals. They are normally placed just above the concrete block. So that so the first one, hold on, based on the spacing. So I'm going to copy this. I'm going to put one here. I'm going to put one here. If you notice, the steel bar is not exactly dead center. It doesn't have to be in this case. This could have been a further over, pushed to the right. Okay, all right. It doesn't really matter that much. All right. So I think that is it. But there is a lot of um, labeling and dimensioning to do. So let me select my dimension layer. Um, so when the person is building, they would need to know the, the thickness of this foundation footing. Let me change the arrow size to about 50 millimeters. You can set up a different dimension style for this specifically. Let me, the text height, let me 75. All right, that is good enough. All right, so I'm going to know from the ground, from the footing to the ground. You would normally want to put an overall measurement here as well, so that in one glance you can actually see the depth of the foundation. You would also put the width of the foundation trench. Let me see what else you would put. You can also put the measurements for this here, or you could also put it in the labeling. Um, Sometimes it's a bit clustered. All right, I'll remove these. You'll see why. Now I am going to label this, and I'm going to show you some import. While I'm labeling, I'm going to tell you what's going on. Let's start with the easier part first. Let me select a leader. I'm going to label the concrete ground floor first. Um, so this is 100 millimeter thick concrete ground floor. All right, so this is too large. The text size is too large. Let me edit the leader style. Let me see what is there. I'm gonna modify that. This is the content. Text height 150 millimeters. Let's use 75 and see what's will happen. All right, I think I can work with this. Let me zoom in so that I can move this over some more. All right, so this is the concrete ground floor. Let me shift this up a bit. I'm going to now, for ease of labeling, I'm going to copy this. This is 100 millimeter thick sand blinding. All right, so basically the sun blinding provides a smooth or a softer surface or a better surface to receive the concrete. Right? It also provides a very cushioned surface for a damp proof membrane which may be placed between the blinding, the sun blinding, and the concrete slab. That prevents moisture from seeping under the from under the floor, because you have the earth, you have the hard core, so moisture may seep up. Now this is the hard core, and this is 400 millimeter thick hardcore bed or hardcore, depends on what you want to call it. Um, and if you notice, I've placed the measurements or the thicknesses of the different layers, so I don't have to place it. I don't have to place it in a dimension as dimension. So I can do the same thing over here. Let me just mirror one of these over here, and you'll point on the wall. And this might take a bit more description. Um, Let me size this down to about 60 so that the text is smaller. So this is 150 millimeters thick, and sometimes it's best to use the, the shortened form of the word. With block pockets filled with 1 to 2, sorry, 1 to 3 to 6 concrete mix. All right, so let me explain this last line. Basically, concrete is a mixture of cement, sand, and gravel and water right? So in specific proportions. So this ratio here represents the ratio of cement to sand to gravel to be used. Normally the ratio is listed in the order of the particle size. So 1 represents cement, 3 represents sand, 6 represents gravel. So if you're using a bucket of cement to mix for every bucket of cement you are using to mix the cement to be poured in the block bucket, you're going to use 3 times as much sand and 6 times as much gravel. So that's what this means, right? It's describing the concrete mix that is supposed to be poured into the block pockets. Now there are some more things to label. Let me copy this here. I am pointing on the steel bar, and this is the steel bar is a 12. Let me delete this line out of here. This is a 12 millimeter bar. It's 12 millimeters in diameter. Let me search for the diameter sign. Steel bar. And then you have at 400 millimeters OC off centers. So basically the distance between the steel bars are 400 millimeters in this case. So that's what this is saying. So the spacing between these vertical steel bars is 400 millimeters. I'm going to shift this down a bit. I can shift it down even further because I want to make space for the next description that will be describing this steel bar. So let me draw a circle around this. I'm going to point on the circle, and this is the same 12 millimeter steel bars at 600 millimeters. As you know, the block height is 200 millimeters. So for every 3 rows of blocks that are laid, one of these steel bars are running horizontally. So I'm going to label it as horizontal steel bars, and this is vertical steel bars. So we're coming on nicely. There's one more thing to be labeled, and I'm going to label it right now. Let me check, get this right, and mirror. Alright, so the same thing that was done here, I'm going to do it here. Alright, so I'm pointing on this steel bar right here. Right. So please observe the notation that I'm using. So number 3. Hold on. I'm writing in the incorrect area. Alright, let's try that again. Okay. So number 3, because there are 3 bars, 12 millimeter diameter. That's the diameter of the steel bar. Steel bars. There are 3 of them, and they are 12 millimeters in diameter, with 10 millimeter diameter links. Now, the links that I'm referring to are these steel bars that are placed in the, and they are placed at a certain distance apart at 250 millimeters OC in 1, 2, 4 concrete mix. Now, for different buildings, different concrete mixes will be used. For foundations, this concrete mix is normally used. Depending on the size of the building and the amount of load that the building will bear, this ratio might change. The spacing, this is representing the spacing, the 250 millimeters, that's representing the spacing between these links. You have them along the line. They are running in parallel to the width of the foundation trench. Now, they are using 12 millimeter bars. The diameter of the bars, that the steel bars that they are using, is 12 millimeters, and you have 3 of them. One here, one here, one here. As you can see based on the drawing here, one here, and one here. They are running along the length of the trench, and these bars are running along the width of the trench. I could have pointed on them separately, but to save on space and labeling, I have just pointed on one. And due to the fact that these links are wrapping these steel bars together, or connecting them together, that's why you can do it that way. But you could have labeled them separately. So basically, this is the concrete footing, the foundation footing detail. And I'm going to go ahead and label, show you the labeling. So you'd normally write foundation footing detail. Alright, I want this text to be smaller, so I'm going to 100. That is good. Then I'm going to press enter and type scale and 1 into 25, or 1 in 20, 1 in 10. Let me use 1 in 10. Now, this is the scale that you're going to represent this drawing on the paper when you're printing it. Whatever scale you're using, that's the scale that you're going to show. So let me type. Normally, the scale is a bit smaller. It's the subheading. Then the heading here, I'll underline it. So you'll have it like this. So a quick recap. This is the foundation footing. The actual footing, they have the width of the trench that coincides with the foundation plan. You're not seeing the thickness of the trench, of the footing here, the strip, the concrete strip. So it is shown here. So the builder will know how to lay out the foundation here, but they will look specifically on the foundation footing detail to know how much concrete to be poured, how high the concrete is supposed to be poured from the foundation bed. So in this case, it's one foot or 300 millimeters. Then they will know how deep to dig the foundation, which is this distance here. In this case, it's 900 millimeters, 300 of which will be filled with concrete. And they are going to backfill the remainder, meaning after you have after you have put in the steelwork, casted the concrete, and laid the block walls, you're going to fill the remaining space with they refer to it as backfilling. You're going to fill the remaining space with the same earth that you have dug up before, and the excess will be carted away because excess will be there. All right, so Vertical steel bars, they are showing the size of the steel bars, the fact that they are steel bars, and the spacing. The horizontal steel bars, the size and the spacing. All right, so let me see if I can represent the horizontal steel bars. So you have laid the block wall. So you have laid like three, let's say this is the wall, and you have laid it to a certain height beforehand. And you, let's say that you have the steel bars of one here, one here, one here. This is a block. This is a block. And just imagine the holes in the block, because you should know what blocks, concrete blocks are. And before you, let's say this is the third row, you will lay a steel bar horizontally. Then you will continue to lay the blocks. And then another 3 block row, you lay another horizontal steel bar. So that's how they do it. And then you have the description of the block wall, the fact that it's a 150 millimeter thick concrete block wall. The blocks that are used are 150 millimeters thick. Then it is showing you that the block pockets are filled with this concrete mix: 1 portion of cement to 3 portions of sand to 6 portions of gravel, right? And then over here, the thickness of the concrete slab and the fact that it's a concrete slab. Normally they go further and describe this to state even the finish, whether it's tiles or floorboards or whatever the case may be. Okay, I said I was going to do a bit more description. Normally, when you dig the foundation, the inside of the building is dug down a bit as well to receive what we call the hard core. The hard core provides a level, sturdy foundation for the ground floor to be laid, the concrete slab. Then after laying this, you will now lay the sand blinding, which provides an even more even surface to receive the concrete slab. And sometimes on top of the sand, you will have the damp-proof membrane, because the hardcore tends to be a bit more porous than porous, meaning water can travel through. So if the earth is saturated, the water will seep up, or there's the potential of the water to seep up, causing leakage in the slab, or moisture that can cause the growth of what should I call it, like algae and so forth on the ground, molds and so forth. So you'd install a damp-proof membrane to take care of that issue, to prevent the moisture from going up. All right. I think I want to show you. One that I did before, so that you can see how detailed the description can get. Okay, it's right here. All right. So let me copy this. Let me bring it over here beside the one that I just drew. All right. Now, this one is for a building that is a 2-story building. If you notice that the depth of the foundation is different, and for in this case, the foundation, the level of the site is not so flat. As such, the depth of the foundation may vary, but they are stating that it will be no less than 400 millimeters, or sorry, 1,200 millimeters, which is 4 feet. If you notice, this foundation trench is wider, but the thickness of the block wall remains the same. See, it's 150 millimeter thick. And as I realize, I have the same descriptions here. Might look a bit different because the writing style is a bit different. And okay, so MSB here stands for main steel bars. So this looks a bit different. All right, but it's the same thing. And right here, they're showing you the distance from the concrete block wall to the edge of this strip here, the strip foundation. So basically, oh, this is some description. Sometimes, depending on the situation, you provide some description beside the drawing. Oh, and this symbol is normally placed on the ground level to show that it is indeed the ground level. Oh, and in this case, the height, the height of the floor level from the ground level is also 300 millimeters. It can be higher. It is not recommended to be less especially in areas that are flood prone because water could get in your home. There are a lot of reasons why you don't want your ground floor to be too close to the level of the finished floor level, which is this level. But every situation is different, and at times you may need to do that, but you have to put things in place to prevent that. So that's basically it. This is how you draw a foundation footing detail for a strip foundation. Now, some persons will go more specific and write strip foundation footing detail because there is a strip foundation is being used for securing this building in the ground or supporting the load of this building and transferring it to the ground. So I hope you learned um, what was presented in this video today. Please go ahead and practice. If you have any questions, please leave them in the comments section so that I answer them. All right, please like, share, and subscribe and share the knowledge. Have a good day.